Let us discuss this result. So in this result, we have to prove that every singleton set is a closed set. Okay, so let us prove it. First of all, I will write let XD be a matrix space. I will draw here the rough sketch. So this is a matrix space XD. Okay. We are going to select one point from that matrix space. Let A belongs to X. I am taking one point A from a matrix space XD, and our target is to prove that singleton A is a closed set. To prove that A is equal to singleton A is a closed set. See how to prove a set is closed, or in other words I can say what is the definition of closed set. If its complement is open, we can declare it as a closed set. So that means now our target is to prove that X minus A is open. So you know the procedure to prove any set is open. We take one arbitrary point of that set and we draw open ball around that point, okay, and we prove that that point entirely lies inside a set. So then we can declare it is a open set. So here also I am going to do the same thing. Let X belongs to X minus singleton A. I am X. I am taking one point from X minus capital A, that means X minus singleton A, since A is nothing but singleton A. So implies X does not belongs to A. X lies in its complement of capital A, so therefore X does not belongs to A. That means X does not belongs to singleton A, since capital A is nothing but singleton A. Which means X and A, these are two different points. Getting? So X does not belong to singleton A. So if you have two distinct points, definitely there is some non-zero distance between them. So therefore I can write implies T of X and A, distance between X and A is greater than 0. There is some distance. Getting? I will call it as R. So let R is equal to distance between X and A. Obviously it is greater than 0. So now my claim, that means our target right now, to prove that open ball with center X, radius R is subset of X minus A. Getting? What is our target to prove that? Open ball with center X and radius R, getting? I will show here, is subset of X minus A. How to prove that one set is subset of other? We take one point from this set and we will prove that it is in second set, so that then we can declare first set is subset of other. So let us take one point. Let P belongs to BXR. I am taking one point P. I will show you here. Suppose one point is here. P belongs to this open ball. That means distance of point P from center of ball is less than R. So therefore distance of XP is less than R. But what is our R? You remember, yes, definition of R is dxa. So therefore dxp less than dxa. See what I'm going to do, I'm going to shift dxp on that side, okay, then it has actually plus sign on this side. So if you shift it there, it will have a minus sign. So therefore 0 less than dxp minus dxa, a very important inequality we have got. I am calling it as inequality number 1. You remember triangle inequality? This is a fourth property of that matrix space, definition of matrix space, okay. So by triangle inequality we can write, by triangle inequality, what can we write? dxp less than or equal to dxa plus dap. Getting? So by triangle inequality we could write it. After that, what I'm going to do, I'm going to shift dxa on this side. Actually dxa has a plus sign. If you shift it here, it will have a minus sign. So therefore dxp minus dxa less than or equal to DAP, inequality number 2. Can you find any similarity between inequality number 1 and inequality number 2? See, right hand side of inequality number 1 is same as left hand side of inequality number 2. In a simple language, we can say if you have A less than B, B less than C, then we can write A less than C. So same thing we can do here, but you can make a screenshot of it, then we will go further. See, now from 1 and 2, what can we write? 0 less than this part and this part is less than DAP. So therefore 0 less than DAP. That means point A and the distance between point A and P is non-zero. That means these 2 points are different, distinct. So therefore we can write A is not equal to P. That means P does not belongs to singleton set A. Getting? So P is not equal to A. That means we had taken a singleton set. Okay, that singleton A. So P is not a member of that set. That means P does not belongs to A. Since we have called this set as capital A. If P does not belong to set A, that means definitely it lies in its complement. Getting? Suppose any person does not live in Ratnagiri. That means definitely it lies or he lives or she lives in a complement of Ratnagiri. Getting? So that thing. So therefore P belongs to X minus A. Basically we had taken point. Okay, I will clear. Let me clear this thing. Let me remove this part. It is not required. Okay. So therefore now I am going to conclude. P belongs to, we had taken from open ball B X R, and finally we proved that P belongs to X minus A. But that point P was any arbitrary point. So therefore we can declare therefore BXR subset of X minus A. Actually, we had taken X was any arbitrary point. Okay, X was any arbitrary point and we could find open ball around X which entirely lies inside set X minus A. So therefore we can declare X minus A is an open set. So therefore X minus A is open in matrix space XD. So X minus A, that means complement of A is open, that means A is a closed set. So therefore A is closed in matrix space XD. We are getting A means what? Singleton set A? No, we have called it as capital A. So therefore singleton set A is closed in matrix space XD. So in this way we can say, okay, we have proved that singleton set is a closed set. So therefore we can conclude now, therefore every singleton set is a closed set. So in this way we have proved this theorem. You can make a screenshot of it. After that we will stop. Thank you. Bye bye.